Alicia, and I'd like to welcome everybody after hopefully not too big of a lunch. I'll try to keep things hopefully nice and light and give you guys a lot of information about kind of how we came into StealthWatch and our unique setup and what we use it for in our day-to-day use. Just to give you a little bit of background about what we have currently on campus, we have approximately 28,000 students worldwide, 20,000 here on our main campus, which is where I reside, 7,000 plus on-campus residents. That includes about 26 different residence halls and apartment complexes that are spread out throughout our campus. When we initially designed our network, we kind of looked at what the needs were going to be going forward in the next 10 years, and we basically designed at least the wired infrastructure as a one port per pillow type of environment. So that leads us to about 35,000 wired network ports across our entire campus. In addition, of course, I'm sure many of you are aware, the explosion of wireless usage over the last few years. So we've added additional capacity to our networks, basically giving that wireless extension of our network that our students so often demand and use just about every day. We have approximately 13,000 wireless access points throughout our campus, and we are a 100% Cisco shop, so pretty much everything we have from our wireless to our wired network, including some of our services and systems in the core, is 100% Cisco. Some other basic information about our network and kind of how we're logically divided to give you a sense of kind of the scope and how we use StealthWatch every day to help us get some visibility. We have our academic and administrative networks, our residence halls and apartments, and our smart zone, like our research center and kind of our corporate branches of our network. So we kind of have three logical areas that we've tried to break things off into, where we of course have different policies and maybe different firewall rules or ACL rules going into those different areas. Almost all of our users have a publicly routable IP address. That's a whole lot of IP addresses. We were lucky enough to be assigned a Class B address back when Al Gore was first inventing the internet, so we got very lucky that we have a very large IP address block. We only use NAT in some very specific applications, so that means that really every one of our network nodes is publicly accessible on the internet, giving us quite an open target for lots of the scanners out there that are constantly scanning our network. So we needed, of course, a good way to be able to look at that and see what our hosts were doing. Our current internet connection, we recently upgraded our internet connection. Before we had two 1 gig connections. We now have gone to a 10 gig connection with two 1 gig redundant connections to our regional ISP Merit. They handle a lot of the government and EDU colleges throughout the state of Michigan. They have core connections into the Chicago Gigapop, so we have a pretty large internet connection, and it does get quite busy during the day. For a IPS system, we initially had the ISS Provenia as our front door IDS and IPS, and we found that when we kind of moved into our 1 gig and 2 gig connections to the internet, we were really pushing that box to the limit. Of course, that's a signature-based IDS solution, so everything that was coming through there, it would attempt to go through and match a signature on that. So we were really bogging that thing down, and it got to the point where we essentially had to pull it out of production because it could no longer keep up with the amount of traffic we were pushing through it. So we needed a way to really kind of beat down the traffic and stop students, especially, from abusing the network. This was 5 or 6 years ago when internet prices or bandwidth prices were particularly high, and we needed a way to really kind of get that traffic down to a more manageable level to allow legitimate traffic to flow through our network appropriately. So what we did is we created a kind of a homegrown solution that summarizes net flows to determine the total traffic consumption each week for our residence hall users. We really realized how powerful net flow analysis could be, but really didn't have the resources to do more than just basic summaries on the traffic. So really IP address, maybe total bytes in, total bytes out, and maybe a few things as far as like port details or service traffic details if we really needed to. So this led us to the invention of what we call our Quota system version 1. So this is really based on one rule. File sharing apps consume tons of bandwidth. I think we all know that and realize that those applications can consume any and all available bandwidth that's available to it. So for our version 1, we originally had the Packeteer Packet Shaper to throttle users, and we created this special group within the Packeteer called the BSA group, or the Bandwidth Sucking Application Group. And really it was based on a simple rule that anyone consuming over 1% of the total bandwidth that they had available was put into this group. The results for this, well, wasn't very accurate, but it was better than nothing, and we were able to develop and put the system in place in under 2 weeks. So that was kind of our first step to try to get our traffic under control. And this was put in place probably circa 2001, 2002, just before I started in the information technology group. As things expanded and continued to grow, we kind of moved into a slightly different version of our quota system. So we called this version 2, and what we did is we started utilizing net flows to collect these traffic summaries from our broader routers. And we created this homegrown system and homegrown database, which we stored in a basically Microsoft SQL database. And at some points, we were exceeding about 10 million flow records per hour, right? Quite a large number of flows. Kind of the basis of this were PHP scripts that would automatically create and remove classes from the Packeteer. So now we're kind of creating a custom system that took action and just put those users in the Packeteer. So we were able to get a little more accurate with this type of systems. And users could then log into the help desk portal to check their current usage. So we kind of built in some custom web page interfaces so users could actually see maybe why they were put into that type of limiting factor. So our first thresholds that we put in place were 3 gigabytes total or 1 gigabyte of upload traffic per week, whichever one was hit first. So this was for essentially all of our residence hall users only. If they hit that 3 gigabyte total traffic or 1 gigabyte worth of upload, they would be put into this basically a special VLAN that only had access to on-campus resources. So it would prevent them from continually spewing or sharing out those types of file sharing applications. Did a fair job of beating down traffic to a more acceptable level. Students could easily get around the system if they managed to obtain a different IP address, right? So this was based on the IP address that a user might have. And we discovered a severe limitation of our Packeteer in that it could only handle approximately 1,024 classes, which we nearly breached at the end of the academic year. So every user that was thrown in there was basically creating a new class. So we had to kind of take even yet another approach to that. So we moved into version 3. So this will collect and summarize net flows for all of a user's systems. So now we were actually integrating our NAC solution to tie in users' MAC addresses and IP addresses. So what we're doing is we use Bradford's Campus Manager solution to automatically restrict those users. So what would happen is our net flow summaries would happen every hour, and if the user violated those thresholds that we would set, we would send a signal to our NAC appliance to automatically place that user onto a special isolated VLAN. Right? So that role was mapped to an isolated VLAN that had access to on-campus things only, right? Things like Blackboard, their email, really on-campus resources that they would need to do their day-to-day work in their classes. So we used that quota system to help kind of place them into a isolated network so that they would essentially hopefully get the hint that, hey, they need to stop doing all this file sharing stuff. We also used a number of other things to help kind of manage our traffic. One of those was the use of the Bradford Network's CSA, which would scan their systems to make sure they had up-to-date antiviruses, up-to-date Windows patches, things of that nature. We also implemented Cisco's private VLANs. I'm not sure if any of you are familiar with private VLANs, but basically what those do is they allow or they prevent communication from machine to machine even on the same VLAN. So we did this to really help stop the outbreak of worms and viruses that we would see from time to time in the residence halls. So if a worm did manage to get inside those residence hall networks, private VLANs would stop that worm from spreading within. Right? So no two users, even though we're in the same room and plugged into different ports on the same VLAN, would no longer be able to communicate with each other.
Brian?
Yes.
Sorry to interrupt you.
Sure.
I think I've had a few people ping me about this too. Your audio is a little choppy.
Okay.
I don't know if you could quickly try to dial back in so we can see if we can get some better audio.
Sure, I can do that.
I'm sorry, everyone, but it is a little choppy, so we see if we can get you a little bit clearer.
Okay, let me dial back in here and see what I can do. Should I sign out of the WebEx as well?
I don't think so. I think you should just try the audio. You should be fine.
Okay. Do you have the number I can dial in with that?
Sure.
I don't think I have that on my screen anymore.
I will email it to you right now.
Okay.
Thanks, Ryan. Sorry, everybody. We'll get them right back on.
I'll try to dial in, and we'll try again.
All right, thanks. Again, I apologize for the technical difficulties here, but we'll have him back on in just a second.
All right, I am back in now. See if hopefully this is a little bit better.
Oh, so much better.
Wow, that's strange.
All right.
Gotta love technology.
Exactly. You never know. Please proceed. Sorry to interrupt you.
That's okay, Alicia. Thank you. Sorry about that, everyone. Gotta love technology. I am actually on a fully wired phone, so it's not a VoIP phone, so it's definitely not a network problem, so I can't blame myself for this one. All right, so let me continue on with kind of where we're at with our Quota system. So I was mentioning the use of Cisco's private VLANs, which is where users, even on the same VLAN, cannot communicate with each other. Right? This was very useful in attempting to stop the spread of worms and things of that nature that can really generate a lot of noise on the network and wreak havoc for a lot of different reasons. We also increased our connection to the internet. All right, so this was on V3, and this is right when we were starting to go to our 1 gigabit per second connection to Merit. So with that, we decided, well, since we're going to kind of start summarizing all of the users' machines together, we wanted to up the thresholds for their Quota system. So we gave them 5 gigabytes total or 2 gigabytes upload per week, so whichever was hit first, either 5 gigs total or just that 2 gigabyte upload traffic. And again, this was user or global ID based, so every machine that the user registered would then be included for that traffic. Well, the results of all this were really the main facts that we don't have to be application police and try to keep up on all the different file sharing applications that were out there. Right? We were just basing the things on a simple fact that these these applications consumed a lot of bandwidth. Right? Now, today we've kind of moved things forward even more. We've upped our quota limits even more because, as you guys may have realized and have seen on your networks, is that they're using the internet connection for everything now. Right? It's not just their schoolwork. It's everything from streaming Netflix videos to Facebook to managing pictures and everything. And these are, from our point of view, these are people that live here on our campus, and we should try to give them as much of those commodities as possible, right? So the internet's really changing in the way people use it every day. So another thing that the Quota system allowed us to do is it seemed to work pretty well in minimizing our RIA and MPA complaints that we received, almost daily. So recently received 24 RIA pre-litigation notices, and we've seen this increase more and more over the years as people get faster and faster connections, and they're doing more and more of the file sharing type of activities. So kind of asking ourselves what are the reasons for these increases in the number of pre-litigation notices. Well, we certainly know they have better tracking technologies now, right? They have people that are sitting out there actively looking to see who's connecting to them and downloading or distributing that material, tracking downloaders, of course. We've also used Bradford Network's Campus Manager connection logs to kind of correlate the port to the IP address to the MAC address to the user, so that if we do get a RIA complaint, we're able to quickly identify the user responsible for generating that complaint and send them the appropriate notice. All right. So with all these complaints coming in, it's great to handle 10 or 20 every couple of months. Well, now we're getting a couple hundred every month. So this is a very cumbersome process to do, and we'd like to put in place a system, an automated system for dealing with these type of complaints, but one that we don't have to really do a whole lot with. So where to next? Well, we certainly think IT should not solve this alone. All right, we want to work closely with our Office of Student Life to help with the discipline of some of these RIA complaints. Of course, increase automation. All right, we don't have the time or the manpower to research every single complaint that we receive, so we want to develop a system that can kind of automate some of this. Automate the distribution of the notices. So if we receive a notice, we can kind of put it through our system and have it automatically correlate that IP address, the date and the time stamp of the complaint. We also have our CSA agent, which is that little agent that runs when somebody first registers their machine to see if it can detect any common peer-to-peer applications that might be on a machine. All right. We know there's certainly dozens or hundreds of those applications, so we kind of just look for the main ones like the Kazas, the LimeWires, BearShare, things of that nature. So just the big ones. All right. We know that list changes, and it's easy for someone to get around, but at least we're doing our due diligence to try to look for those kinds of things. We really wanted to get more visibility into our network. Okay? As I stated before, our system didn't really have a whole lot of visibility that we can get. We just had this basic summary of traffic that we could see. All right? We didn't see what was this traffic. Was it HTTP? Was it HTTPS? What was actually the makeup of that traffic? So we looked at a couple different analysis tools before we decided on StealthWatch. The first one we looked at was the Arbor Networks Peak Flow, which was a great product, but it was really geared more towards your large carrier ISPs. And we looked at it, said, yeah, it looks great, and the price was, well, way out of our ballpark. So we said that one's not going to quite work for our environment. We also looked at Snort, which is a great IDS tool, and we would like to actually implement some more of that in our network as time goes on. But ultimately, we settled on the StealthWatch solution. All right. So why did we decide this? Well, we had very few flow tools that allowed us to look at the details of the network traffic spikes and any kind of anomalies. All right, if we wanted to look at that kind of information, I would have to go into our flow collector and run some scripts. We were using OSU flow tools to gather our flows. And basically all we had were these text files, and we could look at different flows. All right, not very visual, and trying to track down traffic spikes was very time-consuming because having that system crunch through those flows to try to figure out what we were after took a lot of time. We had very limited staff and needed a system that was easy to set up and required very little maintenance. Definitely a big bonus. We wanted a system that was better at clearing out kind of the chatter that's typically found in a signature-based IDS system. Right. Now, StealthWatch does, of course, have chatter, but you can set thresholds that can help minimize that, just like any other really good IDS or IPS system. So we wanted something that can help minimize that and give us the ability to kind of fine-tune it for the events that are typical in our network. Our homegrown flow analysis could only throw up to 3 days of raw flows, not very much. So if we were kind of late on an event or late on a RIA complaint and wanted to go back more than 3 days, so sorry, we couldn't go back and do it. We didn't have that much visibility or any of kind of real historical type tracking. We wanted the ability to integrate it with our NAC solution, all right, our Bradford Networks Campus Manager solution. And as I stated before, we looked at other vendors such as Arbor Networks and ultimately decided on LANCO. One of also the big bonuses was the fact that it could do automatic threat mitigation. So we could have it actually sit there and put in null routes on our routers for certain types of events. If we were seeing scans from China or Romania or wherever they might be coming from, we could have a system set up, and with that StealthWatch system, go into our routers, place a null route, which would then prevent all future traffic going to those networks. This is kind of a graph of now what we could see in our network. So my biggest thing that I really like is this stuff down here. Now we can actually get a graph and see what's actually making up our network traffic. All right, so we can go in and take a look and say, hey, most of our traffic is HTTP or LDAP traffic or maybe SMB, whatever it might be for your environment. So now we can kind of really get this sense of, all right, we kind of know what our users are doing on our network. Another great feature on the second graph here is the ability to kind of zoom in on certain spikes or anomalies. So if I wanted to go in and hone in on a big traffic spike, I could do that, and then I could also go in and get some details on some of the different zones. All right, so you can break up your environment into different zones. We've chosen to do ours via our different buildings. We could then go in and configure the IP addresses that are used for those different areas and kind of get an idea of what specifically each of those zones might be doing for traffic. Another great thing about the system is the fact that now we have sort of the IDS type function of it. All right, so in addition to just gathering flow data, now it has some built-in algorithms that it's going through and looking for different events and generating events for or based on those flow data. All right, so doing a very behavior-based type of analysis, looking to see, is there a machine out there that is doing thousands of connections on SMB port or NetBIOS port? Maybe it's infected with configure. Okay. So those kinds of things we could actually see now in a very visual and graphic view, and we can also tell on either the source or the destination zone, maybe the different countries that those flows are originating from. All right, so now I can get an idea, well, if it's located just on campus, maybe it's someone just doing a local scan, or maybe it's a smart virus that knows to just scan the local subnet. If it's going out and scanning all sorts of different countries all over the world, like Configure does, we would then be able to really hone in quickly as to what was the cause of that traffic spike. Yep. Historical data. Now we can actually go back and for every one of our hosts, we can kind of have this graph of the traffic generated every day for each of our hosts. Right? This is something we never had before. We had very little visibility as to really what our hosts were doing. We did have some with our homegrown solution, but it was a little harder to get at than just going into the system and say, give me a report for the last 30 days of network traffic for this IP address. Right? And it would spit it back very, very quickly. So this was something that we really, really like to see. So that way we could tell if a particular host was doing normal traffic for it. Right? So if I saw a spike going up to maybe 30 gigs for this particular host, I would definitely call that abnormal. All right? So if it was anything in this range here, I might say, well, this looks like it's fairly normal activity for that host. So again, we're doing that kind of great, really behavior-based analysis of what is typical for the host. Also, if you like numbers instead of graphs, we have a nice chart view, the different days of the week, and then the different total traffic for each of those different days. So we can see bytes out, bytes in, highest bits per second, all sorts of great information and historical data that we never had before. Okay. So in order to, one of the bigger reasons why we did choose this system is because it had the ability to integrate with our NAC solution. So if StealthWatch saw an event happen on our network, we could send a signal to our NAC solution, which kind of had its fingers on all the different switches and routers to take some sort of action on those hosts. So we have StealthWatch configured to send a SNMP trap based on specific events to our NAC system. Our NAC system is currently configured to take actions on the IP address defined in the trap. So in the trap, we have certain events within the StealthWatch system that we know are pretty accurate. All right, that if a certain host has a high concern index, or this is an index that StealthWatch assigns to a host that might be doing a lot of scanning or a lot of connection attempts, that concern index is very high, it would then send a trap to our NAC solution, which would then place that user into an isolated quarantine VLAN where the user would have to basically pull up their web browser and do a virus scan just to kind of make sure that things are clean on that system and that all the patches, AV patches, are up to date. We also receive an email notice for each of those different events, all right, so we can kind of keep an idea and see, is one user continuously being thrown into this endless loop of being thrown into that quarantine network. So we also have a couple other different events that we do alerts on, the high target index, so if a host is a target of a lot of different attacks or something else. Also worm activity, so if a host is scanning, I think it's like 5 different subnets, it will then consider that worm activity that probably shouldn't be happening, and our system will send, again, that trap to our NAC solution, which will then isolate that host from the network until that host takes some action. So now kind of some future uses for what we'd like to do with StealthWatch. We'd like to have it send a trap to our NAC appliance when they have something called the file sharing alarm hits a certain threshold. So this is 150,000. It's a number that's assigned to it by StealthWatch that says, hey, this host has a lot of connections to a lot of different places. Chances are it's probably doing some sort of P2P file sharing. Okay. So we could have them maybe put up a warning page that says, hey, we detected all these connections. Maybe you're doing peer-to-peer, maybe you're not. We really don't know that, but it will at least discourage users from running those peer-to-peer applications if they know that, hey, if I start firing these kinds of things up, something could happen to my machine. We'd also maybe like to put this in as a replacement for our homegrown Quota system. All right, so we still currently have this separate database of flow summaries that we're using for our Quota system. So we'd like to maybe use this system as just a replacement. That way we don't have to maintain yet another custom system. We'd also allow our college techs to view detailed information for systems in their areas, right? So the different zones that I showed you on one of those previous slides, we could give the technicians for those various areas access to view that kind of information. And this is something that the system currently already does, but we can do some automated emails of alarm reports, right? So if we see something particularly nasty that we want to make sure that we get an email on, we can certainly configure the system to do those kinds of things. So really some of the key takeaways and what makes this system great is that you can really customize it for whatever your environment requires. All right, you can set the different thresholds. Different traffic is certainly allowed in some networks where it might not be allowed in other networks. Right? The system gives you the ability to kind of look at that and decide maybe you do or don't want to do anything about that. So it really gave us the much needed visibility into the makeup of the traffic on our network. Right? Very affordable solution. Right? It is much less costly than the Arbor network solution, which was one of the main reasons why we went with StealthWatch. Very customizable. It is out of band, which I certainly like out of band appliances. Right? So if this thing breaks, it doesn't really affect anybody. Right? It's just sending flows. All right? Maybe we lose some statistical information or some flow data for a little while, but it doesn't prevent users from gaining access. Has the ability to automatically mitigate threats, right, based on the different alarms and different things that it can see based on the behavior analysis. The intelligence to prioritize those critical events, right, so you can go in and set different thresholds. Say maybe I want to be emailed on these certain critical events, right, like that ability to be able to do that and customize it. Also integrates very well with our NAC solution, and again, one of the biggest ones for us was this historical data, the ability to go back and take a look and see what was this host doing at a particular time.